Okay, so Ayla, you did that first one, right?
Did.
So skewed right, drew in median, and we're gonna remember I just mentioned capital M for the median, and then that lowercase, it's a Greek letter, that's a mu. You guys have heard of mu alpha theta, right? The Math Honor Society, that's mu. Okay, so mu is, because it's skewed to the right, our mean will be farther to the right than the median, but not much. Tessa, you did this one, that roughly symmetric. Mean and median are essentially the same thing, right? Who did this one? Jack, you were this one, right? Mm-hmm. Okay, so because it's skewed left, we know mean has to be farther to the left than the median, but not by much at all on that one, is it? On this one, this was Landon, right? Skewed right. So median is equal areas on each side, and then that mean is gonna be to the right. And then Pragya, you did this one with your really nice handwriting. You have to give me lessons. With your median and then your mean, and then Lisa, there you go. You colored, and that hopefully that there's nothing wrong with shading and doing that if you need to. I'm serious when I tell you guys that I frequently will draw in a line. I've been doing this for longer than you've been alive, and I draw in a line and I look at it and think, nope, I've got to shift it, and I shift it one way, and then I draw that line, and then I erase, and I go like halfway in between the two that I've just drawn. Yeah, it takes practice, so don't beat yourself up over that, okay? All right, onward though. We need to talk, so you gotta flip pages till you get to where we are because we went back to do this. So we're a couple pages ahead now. Okay. So remember, as you are driving, the median is right down the middle of the road, and so that's what we are thinking when we talk about median with our data also. You have to put the numbers in order first, from smallest to largest or largest to smallest, and then we're finding the middle number, which, by the way, if there are two middle numbers, then we average the two, right? So 1, 2, 3, 4, 5, 6, 7. Okay, so our median for that set of data is 4. Our median for this set of data is those 2. So we add those 2, divide by 2, so we get that the median for this set is 7.5. Okay, so if we have data and we want to, this is going to help us with creating a box plot or a box and whisker plot. To draw a box and whisker plot, we have to find the 5-number summary. So the 5-number summary, if you notice, consists of the minimum value, quartile 1, the median, quartile 3, and the maximum, okay? So 5-number summary we use to create a box plot, and it's our minimum value, quartile 1, median, quartile 3, maximum. Okay, so think about what the process is going to be. For this example, if you notice, we are comparing home runs for 2 different baseball players from very different eras as well. So Babe Ruth and Barry Bonds. If you notice, Barry Bonds, one of those numbers is in parentheses. Does anybody know why? It is an outlier, but what else? Do you know anything about Barry Bonds?
His record. Is that his number or something? No. He plays for? That's his record. Is it the cheating record?
Yeah, there you go. So we're not going to count that 73 because they determined that he was doping up and doing things. So we're getting rid of that because that's not really. Anyway. Okay. So if you notice, to find the quartiles, we're going to find the median first. And then we find the quartiles by finding the median of the lower half of the data and the median of the upper half of the data. Because think about this. When we find the median, think about what that means. That means 50% of the values are at that place and lower. 50% of the values are at that point and higher. right? So the median is that like 50th percentile. Okay, so the median for this set of data with Babe Ruth, if we go in order, is this 46. So that's our median. I'm gonna get rid of this just to kind of clean this up a little. And now we want to look at just these numbers, and we want to figure out what's the middle of that set. We're not going to use that 46 that we said is our median. We want to find the median for the lower half of the data, which is this particular value. So that's our quartile 1. And then we're going to find the median for the upper half of the data, and that's this 54. So that's our quartile 3. Okay, so our this is data for Babe Ruth. Our minimum value is 22. Quartile 1 is 35. Our median is 46. Quartile 3 was what, 54? And our max is 60. Okay, pretty straightforward, not too bad, right? Okay, for Barry Bonds, we're not including the 73. We have 2 middle numbers. Yeah, they determined later that he was doping up, so. Okay, so we have 2 middle numbers there. It happens to be the same, so our median is 34. Wow, hello. Goodness. Okay. Our quartile 1 for Barry Bonds, if we look at this list and we find just the middle here, is at 25, and then this 42. So min is 16, quartile 1 is 25, 34, quartile 3 is 42, and then our max is 49. Guys, think about what the quartiles, what that's all about too. Hold on just a second, Ayla. Quartiles, right? We are breaking this up into quarters, in other words. So 25% of the data is in that first interval from the minimum to quartile 1. Quartile 1 to the median is 25% of the data, and so on, right? Okay, Ayla?
Wouldn't the median be 41 because there's 8 numbers and so there's not a middle number, so you'd average the 2 middle? It's like on this one, like 2, 3, 4, then 4's in the middle, then 6, 8, 9, like there's 3 on each side, then the middle number, so that one's just
right.
I mean, here there's 8 numbers, so wouldn't you average the 2 middle because there's not a singular middle?
6.
And then same thing on the other side.
Did I not count correctly? 1,
No,
2,
'cause,
3,
the other one I
1,
averaged
2, 3.
35 and 40.
Okay, are you counting that 73 though?
No.
Like, okay,
1,
I'm seeing.
2, 3, 4, 5, 6, 7, 8. Is there one? No.
We're not counting the 34 on the top because that was our median.
Oh, okay, then that makes sense.
Sorry, yes,
I didn't
we
know
don't,
that.
which, by the way, guys, I'm glad that came up. Okay, finding the quartiles by hand, I'm telling you, for convenience sake, we do not ever count the median. So if there are 2 median values, we're not going to count either of those when we are doing our figuring for our quartiles. Your calculator, your graphing calculator does something very different. So if on a quiz or a test, I'm asking you to find 5-number summary, you need to make sure you're sure about whether you should be doing it by hand or on calculator, because it could be different. Okay, but yeah, we don't count that 34 because that's part of our median. I see what's going on there now. Okay. All right, so there's our 5-number summary for each of those. To make a comparison between these two, we're going to create a box plot to represent these. So I'm going to pause to do that. They don't need to watch for however long that we do this. So we're going to just put points at each of these places. So I want to put a point at, like, I'm just going to move over here. I'm going to put a point at 22. I'm going to put a point at 35. I'm going to put a point at 46, 54, and at 60. So 5 points. And then the 3 middle points, that's where we create our box. So here's our box. Wow, that's really straight. The middle, that's our median. And then we draw the whisker out. And I don't know what this is over here. Okay, so I want to do the same thing with this other graph. So 16, 25, 34, 42, and 49. Okay, and then same thing. So make your box first. That's what I like to do. And then draw in your median, and then draw your whiskers. Okay. All right. Let's talk shape for a second. We talked about this a little bit yesterday, right? If we compare this distance out to here and this distance out to the end, that is larger than these distances going the other way. So that means that this graph is skewed left on this side. Oops, I wanted to make that green. So skewed left. Okay, do you see that? In terms of those differences, the size of the box, right? This is 25% of the data. This is 25% of the data, 25% of the data, 25% of the data. So it's more spread out on the lower end, more condensed, same amount of values in where the bigger numbers are in a condensed area. So that's skewed left. What would you say about the one in the bottom? It's probably a little skewed left, but not quite as skewed left. So maybe a little skewed left. Okay, what are some other comparisons? I'm going to flip this back so we can kind of look at this way. What are some other comparisons that you could make between these two graphs? Like look at Q3 for Barry Bonds. How does that compare to the median for Babe Ruth? Yeah, so Q3 is a little less for Barry Bonds than Babe Ruth's median, right? If you look at Babe Ruth's quartile 1 compared to Barry Bonds' median, those are pretty close. So, yeah, needless to say, looking at this graph, who was the better home run hitter? Babe Ruth, right? Okay. If I ask you to make some comparisons or to describe stuff in the graph, that's what I would be looking for. I would be looking for you to talk about the shape and then make some comparisons like, the Q3 for this graph is almost the same as the median for this graph, that type of thing. So that then you from this should be able to say, visually we can see that Babe Ruth's home run numbers are definitely better than Barry Bonds', right? Does that make sense? Okay. All right, we need to talk calculator stuff and do a few other things. So that's it in terms of the notes. I also do want to talk with you a little bit. I want to answer any questions you have. I'm going to wait to go over that worksheet so that you can finish it. I want to address any questions you might have to help you with finishing the worksheet that you did, that I asked you to work on.